Alrighty, hello everyone. This is Red here with Hackers Club. This is our 5th webinar. Thank you so much for joining. And let me know where you are. Throw it in the chat wherever you're joining in from today. That's geographic and how you found us too, because we're on Eventbrite now. We still got our Discord and we're streaming from YouTube live here. So we're consolidating from a few different places to get you all this good info. So today, we're looking at smart contracts. Exciting. We're looking at sort of the what, why, and how of smart contracts. And then we're going to look a little bit at Solidity, the programming language that is the most popular programming language for building smart contracts on Ethereum or other EVM-compatible blockchains. And then once we do a little bit of that, we're going to hop into Remix, and we are going to code a couple of our own smart contracts, and we're going to interact with them. So a lot of exciting stuff for you here today. I'm going to give it a couple minutes and let people trickle in before we get started with the fun stuff there. And one more very exciting thing is after we hop into Remix and look at some smart contracts, we are going to look to you all, the audience, our community here, to share like maybe a project you're working on, maybe a project you're not working on, but you're just really interested in. And it doesn't even need to be a protocol. It can just be a concept. Maybe you're really digging into ZKs lately. You think it's cool. You want to chat about it a bit, ask some questions. Maybe you're building your own thing. So if you got any ideas, hold on to them. We will put a StreamYard link in the YouTube chat at some point during this. And then you're going to be able to hop in, share your screen, talk to us a bit. If you're not able to share your screen, maybe you're on mobile or something, you can still just put some notes in the chat and I'll talk about it. We'll bring it up. We'll dig into it a little bit. It'll be fun. Cool. Who do we got in the chat here? We got someone from India. Awesome. Someone from Germany. Awesome. Someone from Sydney, or it's Sydney from Collins, Idaho. Yeah. Aragoon is in here from Germany. And Anshuman is here from India. Welcome, welcome. Awesome. Look at this. We got a global team here. I'm based out of Denver, so I'm in the States over here. It's about 1 p.m., but whoever is joining at a weird time, we appreciate it. Thank you. All righty. Yes, and one more thing before we get started. A couple people asked in the Discord what was going on with organizing these events or finding the time for them and stuff like that. So I just wanted to share that in the future, we are going to be hosting on our platform. You'll find out what that is in the near future, but stay tuned for an official announcement. We're shaking things up a little, and we got some exciting plans for you guys on how we're going to host these and what's going on with the videos and the webinars in the future. So stay tuned. It's coming. All righty. I'm going to share my screen here. And we are about to get started. Cool. So, as mentioned before, smart contracts. And very quickly, we are going to discuss what crypto is and what it isn't, because a better understanding of what these things are gives you a better understanding of why you might want to use it. So, crypto is not about being digital. It's not, the whole idea is not, oh, the money's digital. That's cool. The idea is that it's about being self-sovereign. And about interacting in permissionless and trustless environments. So that's what I would call the core idea behind crypto, and that carries over to smart contracts as well. The idea is not, okay, the contract is digital. It is a whole slew of other things about ownership and trustlessness and the ways you can interact with it. So if we want to get technical on it, a smart contract is a self-executing contract with the terms of agreement being between a buyer and seller, and then all that is written into code. But a simpler definition, one that makes a little more sense off the bat, is that it's just a digital vending machine, because that's all it is. You put something in, you get something out. Following this analogy, I can see what's in the vending machine, before I put the money in. It's going to do the same thing every time. There's no surprises. I'm not going to put in C60 and it's going to give me a different item. And the vending machine doesn't really care who I am. It does not care my gender or my geography or what color my hair is. It's going to give me the candy bar regardless. So we love that. But a bit more on those characteristics that I mentioned, or what make this so special, not that it's just digital, are that it's deterministic. This means every time I put in the same inputs, I get the same outputs. It's super predictable, and that's very important for being able to trust what's going to happen next. It's cryptographically guaranteed. So what the underlying faith in this system is that the laws of physics and math aren't going to suddenly change. And if they stay the same, the contract's going to keep doing the same thing. It's also transparent. So any code you write to a blockchain is going to be public. And, things have to be public on a ledger this way because you have to be able to verify them and everyone has to be able to reach consensus. That carries over to smart contract functionality too. So when we're dealing with programmable contracts, the source code is just, plain text online, and that's great because that means anyone can go audit it. That differs from, centralized entities we're used to, where maybe some things are closed source and it's opaque and you don't know what's going on inside. But with smart contracts, the code itself is completely transparent. And that extends past the code. That also extends to what's happening with the code and what's being collected. So if you look at something, let's look at Amazon. They're collecting your data when you use their services. But do you know what data they're collecting? We don't even know exactly what data points they're collecting. And it's just serves for this really opaque system where you don't know what's going on. Data is being collected. And if you're dealing with a smart contract, it would be very clear what is being collected. Everyone would know. And that's not to say all of your sensitive data is now plain text online. You can use zero knowledge technology to obfuscate some of this and keep it private, but it means it's a level playing ground and everyone can see what's going on. Now, past that, it's permissionless. As I mentioned with our vending machine example, a smart contract doesn't care who you are. You're operating in a pseudo-anonymous environment. Your identity is a string of numbers. It's your wallet address. So no one really knows a lot about you. You can't be discriminated against in ways that we're maybe accustomed to in our day-to-day lives. And it's not going to care who you are. You can interact. Peer-to-peer, another great quality of this system is that you're not dealing with middlemen. You're dealing directly with whoever's on the other side of this interaction. So I don't need my deal brokered. I don't need a person or a company to act as some escrow. And that just takes out a layer where, if a middleman is not providing security, if the smart contract is doing that, the only purpose a middleman might serve is to take a fee, slow things down, add computational complexity. It's just not necessary when you're dealing in this trustless environment. So being peer-to-peer is great in this sense. And as I just mentioned, it's trustless. I don't need to trust who's on the other side of my interaction. I just need to trust the smart contract. And it has no ulterior motives. It's just code. Yeah, so being deterministic, predictable, being cryptographically guaranteed, and being transparent are very, very obvious. The three that are not so obvious on why we might want them so bad are the permissionless, peer-to-peer, and trustless aspects. So the reason we would want those so badly, and we do want those so badly, is because there are a lot of issues with paper-based agreements. And I will call a paper-based agreement anything that you're used to dealing with, up until a few years ago. So that's terms and conditions with a centralized company. That's even laws, local government, whatever in your region. It's really any rules of engagement with a centralized entity. So, that could look like I'm using Twitter and now they decide, actually, you're not allowed to tweet about certain stuff. We're going to change the rules. We're going to kick you off it. That's looking like, I use my bank account for all the different things I use it for. And suddenly maybe Chase Bank says, we don't like crypto and we're going to freeze your account if you send some money to crypto things, which happens with a lot of big banks. So, you think, hey, this is my money. I can use it however I want, right? Well, not the case. When you're dealing with a middleman and it's not in a peer-to-peer environment, people can change the rules on you. You have to trust the centralized entity, the middleman, to not change the rules of engagement or to play fair or, and they can exclude you for certain reasons, geographically or whatnot. And, that's why smart contracts offering this is very important, because you might think that you're operating under a certain set of terms and conditions, but the reality might be a little bit different. But that's not the case with smart contracts. That's what we love about them. Again, deeper into paper-based agreements is it's kind of the difference between can't versus won't. So when you look at something like Tornado Cash, it's a contract that got sanctioned by OFAC recently. And now if you interact with anything on the sanction list, you're committing a very serious crime. And the difference between a smart contract and a paper-based agreement is the difference between can't versus won't. So it's, in the case of Tornado Cash, if someone wants to add some censorship, if you're dealing with smart contracts, it's baked into it whether you can do it or not from the start. So if you didn't add any ability to censor, you can't do it. So if the government says, hey, we want you to censor this, you would say, I'm sorry, I can't. And if you were to say, I won't, you're dealing with legal implications. So the difference between can't and won't in that case is like 30 years in prison. The difference in can't and won't, if I bet on the Broncos to win, I'm putting up $20, I give it to someone who's in escrow, someone else puts up $20 and the winner wins this money. Now, if I'm dealing with a smart contract, I know they can't be a bad actor and take my money. And that's better than trusting that they won't be a bad actor and take my money. It's great to deal with people you trust and organizations you trust, but it's even better to know they couldn't do it even if they wanted to, rather than I trust that they won't be a bad actor in the situation. Yeah, back to paper-based agreements. They're not deterministic or transparent or peer-to-peer or any of those very nice things that we just mentioned. So that is why we want to build with smart contracts. These are examples of paper-based agreements that I thought were, kind of ironic or funny things that happened. This happened last week. A guy in Lebanon robbed a bank to get his own money back. That sounds like a joke on The Simpsons, but things like this happen. You think it's your money, you can't get it back, so let's build a permissionless system. And there's a couple more things like that. Now back to blockchains and crypto, the pseudo-anonymity, I always have trouble with that word, the immutability and the decentralization are what allow smart contracts to operate in this way. And they directly permit a few of the qualities. Pseudo-anonymity allows you to have permissionless contracts. Immutability gives predictability and trustworthiness. Immutability is something we will talk on more. After I show you guys some Solidity, we're going to look at USDC's contract. That is Circle's stablecoin. It's, I think, the largest stablecoin by market cap, or maybe Tether is. But immutability is not, there are ways around the double-edged sword where that can hurt you. So they actually use proxy contracts. So you might say, well, it's immutable. What if I want to change something later? What if I made a mistake? If you are preemptive and thinking ahead, that is something you can deal with. So, decentralization, the last one. Decentralization is what allows everything to be peer-to-peer. So that is why we love that so much there. And how to implement them. There are a lot of smart contract networks, usually referred to as, your layer 1 smart contract networks are the more popular ones, but not every blockchain can support smart contracts. So Ethereum can, that's the biggest, and Solana supports them too, and then Avalanche and Cardano and all these others, they let you deploy smart contracts, but not everything does. So Bitcoin, for example, you cannot deploy a smart contract on Bitcoin. It wasn't built for that. It doesn't have the capability for it. It was just intended for other purposes. It was intended just to be money. But Ethereum, the first smart contract network, was intended for programmability. And Solidity is the programming language that's mostly used for that. That's what this little pink icon is here, is Solidity's icon. Not everyone uses Solidity, though. There are other languages, even for Ethereum, that you can use, but I highly recommend using Solidity. There's just so much documentation on it. It's great. And like I mentioned before, the transparency, everything's open source. It's so great. Everything is open source, which means if you find a cool contract you like, you say, Bored Ape Yacht Club made an NFT contract, I want to know how they did it, you can just look. It's all out there. And, you can take inspiration from it and play around with it, test why things work and why they don't. It's really great. You learn best security practices that way. But other networks are not using that. Other networks are still transparent. You can still look how the code works under the hood and all that. Solana, for example, uses Rust. Rust is pretty similar to C++, but Rust was not developed just for smart contracts. Rust has many other use cases, so you'll find tons of documentation for non-crypto stuff as well. And then there are other chains like Avalanche is one that's EVM compatible. EVM is the Ethereum virtual machine. That is how this code is compiled when you're dealing with Solidity and Wiper and other languages with ETH. And a lot of networks said, wow, ETH is the big one. Everyone uses this. All the devs know how to use Solidity. So we are going to make sure we're compatible with it, just to gain some of that market share of all the devs that are learning Solidity right now, like you guys. Now, before I jump into Solidity here, I'm going to ask if any of you guys have questions. I'll answer a few of them right now. Let's see. We've got a question from Tree Poetry. What if there's private functions in contracts so they're not seen to the public? That is a good question. So in Solidity or in Solidity or any of these programming languages, in a smart contract, you can set permissions for who can interact with certain functions. So I could make a function and I could make it owner only, which means if I deploy the contract, I'm the only person that can use this function. You might need that because what if I'm changing something very important? What if I'm setting the price of my NFT? I don't want anyone to be able to go in and do that. So I'd set it to owner only, or I would set it to, internal or private, just not some external public function. But that doesn't mean it's obfuscated. That doesn't mean it's private or not visible. So everyone is actually able to see a contract regardless of who has permissions to use that function. So every last little bit of that function, private or not, in terms of who can interact with it, is not private in terms of who can see it. So good question from Tree Poetry, but not something you have to worry about. And the reason for that is, like I mentioned, a blockchain is it's just a public distributed ledger. And everything on that ledger has to be visible because every single node has to be able to independently reach consensus and decide this is what happened. We all agree on that, mint the next block. This is now written as fact. And if anything was not visible, you wouldn't be able to check it in that way. So I mentioned not all your sensitive data has to be there because you can use some hashes and encryption to, maybe just prove a hash against each other instead of prove the actual data. But when you're dealing with a smart contract, it has to be referenced later at any point. I could deploy it now, and 500 blocks later, I want to come interact with it again. So it actually has to be public because I have to be able to view it again. It's not like a proof where I'm just checking true or false. Did this happen? I need to go through the steps of that function. So you can't boil it down into a single hash like you can with static data because it's a little more dynamic here. So yeah, everything's public. Alrighty, I don't see any other questions on smart contracts right here, which means it is time for Solidity. We are gonna jump into that next. What I've got open right here is the official Solidity docs, and do not worry, I'm not gonna read through this whole thing. That would be a little boring. So we're just going to jump to the parts that I think are very important to understand, especially if you're new to this. And again, if you have any questions while I'm going through this, just throw them in the chat and, I'll jump into them in a bit. And again, if you want to share anything too, if you weren't here in the beginning and you want to share some information about a project you're working on, be ready because we're going to drop a StreamYard link and we're going to let you guys join in here. So that'll be on YouTube. We're going to let you join in, talk to us for a second, tell us what you're working on, what's cool, what interests you, consensus layer, application layer, all the cool stuff. So yeah, stay tuned for that at the end. Now, basics of Solidity. One thing you're going to see on all these, you're probably used to this if you're publishing any open source code, it's identifiers for how the code can be used. So you probably just stick an MIT license up there. But your license and your Solidity version are the first things you're going to see in every file. Pragma Solidity just refers to what version am I using, and the compiler version is slightly different. So this is probably something you're not used to if you're using like Java or JavaScript or Python, like specifying your version. But I promise it's not as intimidating as it looks. You can put ranges as well. Like I'm using 0.7 through 0.9 and make sure your code's compatible with that. But it's not something that changes terribly often. So not something to worry about too much. But those are a couple things that go at the top of every file. And you're going to need, or else you'll get some errors about how it's errors from the compiler, that is. So next, we are going to look at types. If anyone writes in Java or C++, you're going to be very happy when you try to learn Solidity, because you're barely going to have to do any learning. The types that you're using and the syntax for them is almost the same as Java. It's really awesome. A lot of people start learning with Java. It's a great beginner language. So hopefully some of you all have. Also, if you have no Java experience or no software development experience, you can totally still jump in. It's not too complex. Logical operators are all the same. And your integers are mostly the same, except here you get ints and unsigned ints. So this is one important thing to know. And you can also dictate how many bits are in these. So if you're using small numbers, you might want to use a uint8. If you're using something large, you're going to need a 256. Why does that matter? Why can't I use a 256 for everything? The reason is space. When you are writing to a block, so when I'm interacting with a smart contract, what I'm actually doing is writing some code, whatever happened, to the network. And writing code to the network costs gas, because somebody has to, some miner or validator has to compile that into a block. And if I'm writing a lot to the network, I'm taking up a lot of the block space, and I need to pay more gas to make up for that. So you want to save as much space as possible. And when you're dealing with other programs, this might make up 1,000th of a second of time in terms of compiling, which doesn't really matter. So if you're not sending stuff to the moon or making video games that are super dependent on the time for frame rates and hit rates and all that, probably don't worry about this stuff too much. But it is very, very important in Solidity. And this can even be your operators. This can be your order of operations. Very little things make huge differences in terms of gas. That can be down to the operators you're using. If you can find more efficient ways to compare, you should be doing it, because the less efficient you are, again, the more space you're taking up. That means when you deploy your contract, one, it's going to cost you more gas. And two, anytime someone wants to interact with it, it's going to cost more gas. If you guys have been in the space for a bit and you're familiar with NFTs, you might know that sometimes gas on Ethereum spikes to crazy amounts. And that's because there's a limited amount of throughput on the network. So when the bandwidth is met, the gas just has to go up, because if I want my transaction to be on this block, I have to pay enough gas to be on it. If a lot of people are trying to do that, I'm going to have to one-up them and one-up them and one-up them and pay sometimes upwards of $100 for a transaction. It's kind of crazy what can happen when the network gets throttled. And that happens with big NFT deployments, like when Bored Ape does something, things end up costing a lot of gas. So having a contract that is very gas efficient in the first place is great for you to deploy it and anyone who might interact with it. All right, we got a question from Nathaniel. Thank you, Nathaniel, for asking. We got, hello, what are the most important method or functions that every smart contract should have? So I would not say it is a specific method or function that every smart contract should have. It's more safeguards that every smart contract should have. So there are some very common security exploits that happen with smart contracts. One might look like a reentrancy attack. What a reentrancy attack might look like is, I have a contract where you can stake some money with me and then you can withdraw it. And when you go to withdraw, let's say my contract is going to, in 3 lines, here, I'm just going to open this real quick to write a little code. But what a reentrancy attack might look like, I'll just write it down here, is I'm going to have maybe 3 functions in it. First, I'm going to do, send, and I'll send some amount to a specific user. And then after that, maybe I'm going to increment balance. And what that's going to look like is, now I'm going to take that user and their amount, maybe initially the user has 10 ETH, and then they try to withdraw 2 ETH. So what I'm going to do is send user 2 ETH. Where the problem is is for a split second, the user got their 2 ETH back, but they still have 10. I didn't update this yet. So if they could get this in a loop with a reentrancy attack, they could continue to withdraw too over and over and over. So what would be a better idea, much more secure, would be when they try to withdraw 2, first I reduce their amount to 8, and then I send them 2. So these are the more important things for smart contracts rather than that. Let's see, a comment from Anshuman. Let's see, function on its own. Every asset have their own smart contract functions. Cool, yeah. Okay, a function on its own. Every asset have their smart contract function. Anshuman, could you clarify on this one? Was this in reference to Nathaniel's comment? Yeah, so when that comes in, I'll touch on it. Either way, things like this are security measures that the order of operations matters because everything's not actually happening at the same time. I'm not taking 2 off your balance and sending you 2 at the same time. One has to happen first. And if there's a failure at some point, you want to be careful of that. Well, what if the code stops working because I put in some requirement that could not be met, and now I've reduced your value by 2, and I haven't sent you the 2 yet because I tried to do something in between, and the function broken at the exit. That'd be a huge problem. How am I ever going to get that money out? So the order of your operations really, really does matter here. Back to some Solidity stuff for you. Let's see, bit operators, some of the same stuff. I'm not going to touch on any more types right there. What I will type on is global variables and units. So this is something you're going to have to get comfortable with, is Ether units. Ether is the native token for the Ethereum network. The token's not actually Ethereum, it's called Ether, but people use them interchangeably. So 1 Ether is actually a large amount of money. That's about a couple $1,000s right now, but it's much more modular. Like I could send you 0.004 Ether. So what we have are smaller units for that. 1 Ether is actually 1 times 10 to the 18th Wei. Wei is the atomic unit of Ether, and it is the smallest you can get. So a Gwei is a gigawei. You actually have other ones. You have Kwei for kilowei, 1,000. You have Mwei for megawei. But no one calls it a gigawei. They all call it a Gwei. It's a fun word. So when you're dealing with these, there's a number for every other order of magnitude on the way up to an Ether, and then even beyond Ether. But when you're dealing with these, and when you're dealing with smart contracts, sometimes you're not going to post, I want to write 0.001 Ether and send this. What I'm actually going to do is maybe I'm sending 1 million Gwei, and that's 0.001 Ether in that sense. So you have to know how these units convert, and you can just use a quick calculator to do it. There's plenty of websites that'll do that for you, or just use a calculator. It's pretty simply laid out here, but that's something you're going to have to be aware of. You're dealing with atomic units when you're dealing with smart contracts, just to avoid any confusion, have no decimals, anything like that. Very important to know. Time works the same. It's always kind of a mess in programming, but we have some very, very helpful global variables that are going to help you with time. Global variables here, you're going to be using a lot. Here we have a list of some of them. So if we look at the block difficulty, the block itself is an object that's a global variable. You can reference this whenever you want. You get the block difficulty. The block difficulty relates to the mathematical function that kind of using for proof of work there. The gas limit, the block number. These are time in relative to the Ethereum network. So when you're trying to calculate time, if you're dealing with a function that needs to happen, we use NFTs as an example again because they're real common. A lot of people like them. If I want to make an NFT contract and I want to say no one's allowed to mint until this specific time, I can add in the time. Or if I say no one's allowed to mint until this specific block, I can put that in too, because blocks are not predictable to that extent. There's variation between a few seconds. So if anyone's familiar with the merge that's happening, Ethereum, the consensus mechanism is moving from proof of work to proof of stake, the time that's measured in is blocks. So we know the specific block height it's going to happen, but we don't know what time it's going to happen. It's probably going to be like September 16th or give or take a day or two, I believe, is the time range. We got it down to a range, but we don't know the exact second yet, the minute, the hour. So as we get closer, we'll figure that out. The variation possibilities become smaller, but that's measured by the block number. And that is a time that is completely reliant on Ethereum network itself. So this is a more internal value you're dealing with here. But it's not all about the block. That's not the only object you're dealing with. The message is another one you're going to be dealing with a lot. When you're dealing with a contract, message.sender is something that you're going to deal with very often, because message.sender is telling you what address is interacting with this contract. So if I write a contract and I need to check the wallet of the person that tried to interact with it, I would use message.sender to say, okay, this is the address. This is the person that sent this message and interacted with this contract. Now I can take a closer look at them. Yes. Cool. Clarification from Anshuman. To be more clear, I was thinking every token or asset has its own smart contract. That is 100% correct. Every single token does have its own smart contract. So Ether is native, the native token of the blockchain. But what about ERC20s? Or what about native tokens on other chains? What about Bitcoin? What about Solana? These have their own details to them, and they operate in their own ways. So this also comes into play maybe when you're dealing with the inflation or the maximum supply and what's going on there with tokens. If I only want, if I'm building Ethereum myself and I only want 100 Ether to ever exist, but I'm creating new ones every time blocks are created, well, you have to stop or taper off towards that limit, as you approach the limit. So these are things that are unique to all tokens. If I have let's see, Chainlink is an ERC20 token, which means it is not the native token for Ethereum, but it is a token on Ethereum. So if I have Chainlink and I have USDC is another ERC20. They both have their own contracts. And actually, we're going to look at USDC's contract and look at what specifically builds that contract and how what functions they put into it. We're going to look at that today. So as soon as we finish going through a little bit more of the docs, things that, just good to start to absorb because you're going to come across them a lot and use them a lot. We're going to look at USDCs, and it is unique from all the other tokens. It has its own small intricacies, and then, whatever the company decided to put in there is in there. What's great is, like I said, open source. We can audit it ourselves. We can look through every bit of it, and super helpful for us as developers as we're learning this stuff. Now, the last important special global variable is the transaction. And the gas price and the origin, sender of transaction right here. Very important when you ever need to reference these things. So it's like when I start a contract and I want to interact with stuff, here's just like my set of all my basics of internal things I might need to deal with. This also helps you when you're working on a front end. When you're working on a front end, it's nice to be able to call some of this stuff when you're looking at a transaction on the network. So I'm done with these global variables. I don't think there's anything else you guys need to know right now with reserved words and such. But we'll pop into, this is something you might want to look at as well. It's just a little cheat sheet. Again, these should be super familiar if you know Java, C++, or other languages here. But this is a bit more of a comprehensive list of all these things. So these are just pretty much everything you're going to be using. I mentioned before, a function could be public or it could be private. It could be external. It could be owner only. That's where some of these things pop in when you're declaring the function itself. And then modifiers as well. Maybe you want to inherit data from another contract. Maybe I want to call this or import some stuff from another contract because, we're building on the shoulders of giants here. Let's use some really good existing stuff like Open Zeppelin's contracts. Maybe I want to override a function though. I'm using a few things and there's this function with the same name. I don't want it to work this way. I just want to change one bit of it. I can import it, then override it. So again, ideas that are pretty consistent among other programming languages. Nothing here is too earth-shattering, but very good to know nonetheless. Whether you're a beginner or experienced, there are always subtleties in languages, and it's good to have these docs. So there is a ton more stuff on here that you guys can look at on your own time, like Yule. I believe that's extrapolation of Julia, a different language. But docs.soliditylang.org. We'll throw a link to this in the description of the YouTube video after it's finished. Let's see. Yeah, open source OG, love it. And Anshuman's a JS guy. I'm a big JavaScript guy, but even bigger TypeScript guy. Solves your problems before you have them. Yeah, so it's really great what we have here. I'm going to ask one more time, throw in any questions if you have them. In the meantime, like I said, I'm going to go to Etherscan.io, which this is the block explorer for Ethereum. Every network has its own block explorer websites. You could make your own block explorer website if you wanted, because this stuff's all public on the network. So it's similar to the way you might mine or validate the network. You can just pull the data, aggregate it, and make a nice, pretty interface for people to use. But this will let you look at what's going on with your contract. If I want to take my wallet address from up here, my MetaMask or something, and I want to look up some of my transactions that have happened in the past, I can just take that, copy it, paste it in here. You can put ENSs in here also. So I don't know if any of you are into that, but what we're going to do is search USDC, and I'm able to I'll close this. I'm able to search that in plain text because USDC has, let's see. Yeah, USDC has labeled themselves. So they've went in here and they've said, this is our contract. We want to put the name USDC on it so it's easier to find. Coinbase does that with some of their wallets. That way, if you look at a transaction, they pool stuff together. So if I'm looking at my own account, I might see Coinbase 1, 2, or 3 as the wallet it's using. Yeah, and in this case, USDC is labeled themselves. So all the data about it's here. I can see the max supply, how much is out there. We got 43 billion. That's the market cap, seeing as every USDC is equal to $1. That 43 billion USDC tokens equals $43 billion. We can see all the holders, all the transfers, the contract decimals, the official site. Circle runs this, and they verify themselves as the owner, which we will learn in a later video. You'll learn how to verify a contract you publish. But they have verified themselves. So they were able to add all this information. Nice for anyone who wants to go check it out. If I want to go open the Twitter account from here, I can go see what they're tweeting about. But what we want to see is the contract. These are, look how much stuff is happening so fast. 20 seconds ago is when this page updated. Kraken 10, as I mentioned, an ENS name, Uniswap labeling their own contracts here. So everything is public. We can see what's going on with all these, but what does it mean that a multi-call is happening or a transfer is happening? You can jump into the contract to figure that out. Important things to note. You can look at the code. You can look at, you can read the contract. This lets you interact with any read functions. These cost no gas. I can just check these. The write contracts, these do cost gas because this is where I'm actually interacting with the contract. Think of the difference between getters and setters, with your fundamentals of coding. If I'm dealing with some getters, I'm just calling. I'm not really doing much. But if I'm setting, I'm interacting with the contract, and I now have to write to the network to store this new value. So write contracts will cost you gas. That's why it asks me to connect here, this connect to Web3 button. I have to connect a wallet because if I want to use any of these, I'm going to have to give a little bit of Ether. What's on here that you won't see on many other contracts is read as proxy and write as proxy. So Etherscan has identified this as a proxy contract. If you guys are familiar with your software development design patterns, this is a facade pattern. Now, what that means is, if we go back to the code, when a function is called on this contract, what it's really doing is not operating in that function. It's just calling another function. So it's just an interface is all this contract is. And all it does is interface to another contract. If I want to call fallback here. Well, actually, this is an internal function. It's going to call fallback, but let's find an example of this where it's going to call another one. Implementation. Yeah, just calling an external function for implementation. Pretty much any function I interact with on this, it's just going to point to a different contract and operate on that one. And if we remember talking about these things are immutable, well, that's a concern, right? I don't want someone to change this contract last second. Well, they can't anymore. So what happens when you look at the admin or the implementation? They've renounced their ownership of this contract. So 0x means no one owns it. It's like a burned token, which means they're not the owners anymore. They can't change where this facade points to. So it's locked into the proxy. So this proxy is now the permanent contract for USDC. The reason you might want to do that is if you're testing out some bugs first. Maybe you can always just deploy a new contract, but in their case, they likely wanted to make sure everything was working smoothly before they lock it in place forever, because this is associated with their company and there's all this money involved in it. So now there are a ton of read contracts, and I can interact with all these. And USDC, because they are a centralized company and they choose to be compliant with OFAC and all these things because they're a law-abiding company, they have baked in functions to censor you. So I would argue this is very much against the ethos of Ethereum and cryptocurrency in general. And what I've noticed is a lot of people looking for alternatives such as RAI or DAI, decentralized stablecoins. RAI is a better option there, in my opinion. But looking for options that don't have this ability to censor you. So if you're working with a centralized company on top of a blockchain, it undoes some of the great things about decentralization, but it's not the same as operating outside of a decentralized system. Everything's still transparent, like this contract. They couldn't say, we're going to blacklist you. If blacklisting was not in there in the first place, they'd never be able to do it. So everyone's known this for years, that USDC is able to blacklist if they want to. And the government said, we're sanctioning Tornado Cash, which means USDC decided to also blacklist any address associated with Tornado Cash, complying there. So if they didn't add this function in, that would be the can't versus won't situation. Because they have the ability to do it, they legally have to do it. But if you don't give yourself that obligation and responsibility, it's not really a problem when you get to that. So you can check blacklisted addresses here. And they can also be set by the owner of this contract. This one was not, the ownership on this was not renounced because they still have to do some stuff with it. But yeah, looking at this contract here, we can see exactly what that looks like when you're trying to look at some of this open source stuff. So Etherscan.io, another link that will be in the description of this YouTube video, is going to be your favorite tool when you're making smart contracts, dealing with them. When you deploy your own ones, you're going to be verifying the contract through this too. But that's all we're going to look at for these for now. Now we're going to jump into Remix, and we're going to write a contract and deploy it. Freaking sweet, right? So one more time, I'll remind you, in 10 minutes or 5 minutes, we are going to share any community projects that are going on. So if anyone's got an idea, we'll throw the link in there soon. We'll look at it. Now, first, we're going to make a very, very basic storage function. This is going to be real simple. It's going to be easy to do. All we're going to do is make a getter and setter. So we'll let this be a large variable if we want it to. We're just going to create a number here. And then what's next? We're going to make a getter and a setter, and that's going to be it. So we can take this and make a function called store. We'll use the same exact variable type because if we put in a uint8 here, we might have a problem. What if the number's too big and we're trying to enter one? Or if this was only a uint8 and we took in a parameter as a larger number, could be an issue. So we're going to keep the size the same. And we're going to make this a public function. That means anyone that wants to interact with this can interact with this. It's not some owner-only thing. Everyone can use it. And we're going to, I didn't put a name here. We're just going to take this parameter, num. We're just going to set it to number, our internal variable. It's real basic. You've probably done that a billion times if you're familiar with coding in other languages. And now we want to read that function maybe. So read that variable. So make a retrieve function. Public, again, view returns, and this is going to return a uint 256. Same variable type. All we do here is return number. So nothing very groundbreaking here. This is a very simple function, a getter and a setter. I don't know if I explained this before, but Remix is an online IDE built specifically for Solidity. So you don't have to get some crazy development environment set up, which we are going to do that crazy development environment. Not too crazy, but we're going to set that up with Visual Studio Code, and we'll use Hard Hat and Truffle and some other really cool tools. But right now, we're just going to use Remix, keep it real simple. Browser IDE, right out of the box functionality. You can go to remix.ethereum.org. It'll give you some starter functions. You can jump right in. I think it has a storage function that's just like this. But you can compile, see if you have issues. Remember, we talked about our licensing. GPL is another open source license. And we talked about the Solidity version. Well, we're using 0.8.7 on the compiler. We can pick what we want here. That fits into this gap. So we want to stay true to that range. We want to, remember to put these in, and then just contract storage the same way you might have a, public static void main string args if you're a C++ user. It's a little bit shorter here. And we're going to set up our functions. So let's look into this. Again, Remix all-in-one tool. They've got a virtual machine for you. So I can inject my wallet. I have MetaMask installed up here, which is an injected browser wallet. But I can use that, or I can just use like fake accounts. Essentially, these are just fake accounts that they fund with a bunch of Ether for you to play. This is just a sandbox. So if I go to contracts, 1_storage, that's what I'm writing right here, and I want to deploy that, and go down to my deployed contracts. And I can interact with it. So if I retrieve, there's nothing in there. But say I want to store the value 55. First of all, here's the hash that it happened. Second of all, it looks like I spent a very tiny amount. This used to be 100, a very tiny amount of Ether, some gas to write that, because this is super simple. It costs almost nothing. And now the first time I retrieved it, I got 0. If I retrieve it again, 55. I've stored a number. I have created a storage system on Ethereum. Now, the network itself is maybe not the most efficient way to store large amounts of data, but this is just sort of showing you how you can do it. So if you hop on Remix, another function it'll give you right out of the box is an owner function. Now, looking at this one does have an import. It's importing console from Hard Hat, but other than that, same basics. What's our license? What's our version? First things first. Any imports that we might have, and then the contract. So in this contract, remember the last one, all we had was one variable and 2 functions. In this contract, we're going to have a variable here, an event, which is something we glossed over a bit on the docs, but we can look at right here, and a modifier for the owner. So we'll have a constructor. This sets up your default values. If you're not familiar with constructors, this is when your function is first launched. It's going to set itself up with some basics. So if you want some out of the box stuff, you don't want a blank slate when your function launches, you start a constructor and you set up some variables there. So this emit is going to be for your event. Message.sender. We remember our special global variables, right? The message is an object that we have access to, and we should use it and we will use it. Message.sender is the sender of the current call contract deployer for a constructor. So we're making a call to deploy this, and that's why we are the message.sender when we first deploy it. So this is going to make the owner us in the constructor when we first launch this. And then a setter and a getter, as we just mentioned. Now let's real quick deploy this bad boy too. Owner.sol, deploy. And we've got 2 deployed contracts, owner at this address. Let's get the owner. Let's see, 0x4b, it ends with 2db. 0x4b ends with 2db. Pretty cool. Let's take a different one. I'm going to copy this account. I'm going to put it in here. And then remember, this is private. Only the owner can interact with this. I got to go back to my original account to make this change, because the owner of the account has to make the change. I could have made this a public event if I wanted, then anyone can change the owner. But if I change that, let's look at this value here, get owner, boom, we got a new one. So it is 10 minutes to the hour, so we're not going to have time to look at a payment splitter. But this is some code that I will share with you guys, a very, very basic payment splitter, something you might want to use in the future. And if anyone has some time after this, I will be in the Discord, and we'll be chatting about this stuff. But for now, what I want to do is see if anyone has a project they want to share. So someone else on the Hackers team should be putting a link in there if anyone wants to share a project. And it also doesn't have to be a project. It can also be what you're learning about. Maybe you've been doing some reading, or maybe you're curious about like layer twos. Either join in. I'd love if you talk to us about it, or ask me, and I can share any knowledge I might have on it. I know this morning I was doing some reading on state channels, which is a type of scaling solution. It's how you can take some transactions, take them off chain, and not have to put every transaction back on the blockchain. So unlike a roll up, I'm not rolling them all up. I'm just kind of putting the final state between many, many transactions between two people. And it'll save some compute power, things like that. So there's a lot of really cool stuff in this space. When you get to things like scaling solutions or consensus, it is really heavy in the math. So like you find your own niche. If you like math and you want to get into zero knowledge stuff, you can jump into Starks and all that. If you're a developer, but you're like not down with all that, math junk, or I'm just like doing equations and there's not even numbers involved, it's all letters and stuff. You can be doing different kinds of smart contracts. There's core development, which is building the blockchain itself. And then there's what I call Web3 development, which is building on top of blockchains. So these functions we're all looking at, we are leveraging an existing blockchain. We're not trying to build Ethereum's application layer. We're trying to use its application layer to deploy programmable contracts. And that's what Solidity and this course is going to be about. We're going to be leveraging a blockchain existing network to build some stuff. Very different than building a blockchain itself, which is some pretty advanced stuff, but it is pretty cool too. So if anyone's interested in some articles or more resources on that, again, Discord's your place to go. We'll have plenty of stuff there, and I'm in there, Kim's in there, Tommy's in there. Our community members are pretty active in there. They'll help you out if you got some stuff. Speaking of that, one thing I wanted to ask is is anyone, one, in high school, two, looking to participate in a hackathon? Because in the Hackers Club community, we have two now actually that we're looking, two people in high school that were looking to participate in a hackathon. And the hackathons they were looking at had a requirement that you have to be in high school. So if anyone's interested, we've got people looking for the resources and the team members that can work with. You know where to find them now. And is anyone in the Discord watching actually? So there, there's the YouTube, but there's a couple channels to look at this. So if you're in the Discord, drop your name too and say howdy. We're a little bit fragmented, but we all end up uniting through this stream here. So wherever you're watching from, we got a pulse on you. Let us know you're here. We'd love to hear it. And further than that, if any of our Discord members are in the YouTube chat, you can say hi to yourself there. Cool. So it looks like no one has a project they want to share right now. So I'm actually going to write this payment splitter for you guys. Looks like we got a little time back because we're going to end this thing in 5 minutes here, but there's plenty of time for us to make a real simple one. So what we're going to do for a payment splitter. First, when do I want to use this? Well, let's say I am dealing in a trustless environment, as I mentioned, where maybe I don't know everyone I'm working with, or maybe someone hired me as a freelancer for their NFT project, and they want me to write the contract. But these people don't know me very well, and we just want to have that trust built in. Again, why would you want to trust that someone won't screw you over when you can know that they can't screw you over? So rather than I make the contract and I make the payable function for the NFT, there's 100 ETH in there. Everyone bought out these NFTs. I could make all that money go to my wallet and then I'll send it to the team. Or I could send it directly to the team. I could make them the recipient. What if there's not a wallet address just for the team? But if there's people not on the team, you got to pay out. Well, I got to pay out the artist, right? They get, X%. So let's say I want to just send it to not a person's address, but a smart contracts address. So I cash out of the NFT project and I do the withdrawal function, and I'm going to send it to a payment splitter. What this payment splitter is going to do is it's going to take some predefined amounts and addresses and split it up. So whether 50 ETH goes into this or 5 ETH or 0.5 ETH, it's going to split it up percentage-wise. We'll make one that does that, and we'll make it split it up between 5 people. We'll say there's one founder who gets half of it, and the other 4 people get 10% each. So no matter how much gets sent to this address, it's going to split up and it's going to go to those people. So what we would need for this is, we've got our contract payment splitter and function, withdraw, external, payable. Let's add some addresses. So an address is also a custom type for Solidity because you're dealing with ETH address so much that it has its own custom type. Very helpful. We'll call one address 1, and let's see, I need an example for this. I'll copy this and throw this one in here. And let's see, we need address A2, and I'm just gonna copy this so I can put it a few more times. We'll do 3, we'll do 4, we'll do 5. Now I can go and get a bunch of addresses from here because our very handy sandbox has them for us. So in real life, I would need to get the addresses from whoever I'm working with. You don't want to be sending your money to some random place because you're not getting it back. It's lost in the void. As we mentioned, things are immutable. There's no takebacks. So you want to be very careful sending money around. It's pretty sensitive in this environment. And now we're going to need amounts. So we'll take a unit 256, take the balances, right? And what we'll do for that is we can take address, this dot balance. What does this mean? Address this dot balance. We're going to take the balance of this current address. So this payment splitter, it's going to have an address just like your wallet does. We're going to take the balance of it and let's multiply it by 50 and divide it by 100. That'll give us 50%, right? We wanted to give half to the our project founder here. So let's do that. And then, for simplicity, I'll just copy this thing here. And we can change all these. So 2, 3, 4, 5. But we're not giving everyone 50%. These people make up the other 50. So someone, lead dev gets 20 and the other 3 devs get 10. That's how we'll break it up maybe, theoretical. That's great. We've set our amounts now. We've done the math behind it. Let's pay them, right? Require, payable, and we'll do this for each one. So A1, that address is gonna get paid their balance. So 1 goes to 1. Balance 1 gets paid to address 1. Balance 1, address 1, boom. And with something real simple like that, we now have a payment splitter. I can deploy this on the network and I can call it whenever I want. I can call it, if I have a team, I can call it this week, next month, 2 years, whenever. I can reference this in other contracts. So, I'll deploy contracts and this is just my go-to payment. It's always done. Maybe people are making donations or this or that, and we want to route everything through one way. Just a very simple use case of how we might do that. And obviously, if you want to look into it deeper, look on OpenZeppelin for a more complicated payment splitter. But that is all we're gonna do for today. No more smart contracts in that sense. We're gonna wrap things up here. So I want to thank everyone so much for joining. It's awesome to have you guys wherever you joined from, YouTube, Discord, so be it. We got another comment. Hey, a really awesome session. I learned a lot from Aminox. I love that. Love to hear you learn something. Come join in the Discord if you want to learn some more. We'll be chatting in there. Anshaman, awesome session. Thank you so much. Love to have you here. But I'm going to hop off now. I'm Red. I'm your host today. And we're looking forward to having you on the next Hackers Club webinar. Bye.